Okay, guys, so we're progressing really well, and now we're moving on to the big chunky topic, which is algebra or BMAT section 2 maths. And this is also relevant for the natural sciences out there for section 1 of the NSAA. But without further ado, guys, let's move on. The first question we're going to deal with is BMAT 2019 question 12. It says the point M has coordinates 6, 3p minus 1, and N has coordinates 1 minus p 2. The gradient of the straight line joining M and N is minus 3, and it crosses the y-axis at 0, r. This is what's the value of r? So guys, pause the video, just give yourself a minute. Be sure to be back after that minute. We'll be going through the solution. Okay, guys, so let's deal with this. So hopefully, guys, you straight line. So this is basically a straight line, as you know over here. And when you see this word, equation should be popping into your head. Y equals mx plus c. I know in America they call it y equals ax plus b, but in this case, m is the same as a if you're from America, and c is the same as b. So we know then that we can simplify this to y equals minus 3x plus c, because we know what the gradient is minus 3, isn't it? And we can work out the y-intercept r just by knowing the value of c. So that's basically our aim, to find the value of c. So basically c is going to equal r. I'm just going to make a note over there, right? So then we have the coordinates. So we can do something with the coordinates, because remember the equation m is y2 minus y1 over x2 minus x1. Right? So then if I call this x1, y1, and I can call this x2, y2, then this is going to be y2, which is 2, minus y1, which is 3p minus 1, over x2, which is going to be 1 minus p, minus x1 is going to be 6, right? And then this should be equal to the gradient, which is minus 3. Then we're going to do 3 minus, so you have to be careful, 3 minus minus is going to be plus 3 minus the 3p, over, get 1 minus 6, which is going to be minus 5, minus the p, that's going to be minus 3. Take this to the other side, then I'm going to get 3 minus 3p, right? That's going to be what? So minus 3 times minus 5 is going to be 15, and minus 3 times minus p is going to be plus 3p, right? Then take that minus 3p to the other side, bring the 15 to the other side, you get minus 12 equals what? 6p, and therefore p is minus 2. Right, so now we know p is minus 2, then we know this is 6 minus 2 minus 6, that's going to be minus 7, and then this one's going to be 1 minus p, but I have to be careful, 1 minus minus 2 is going to be 3 and 2, right? And then, guys, we can really do something with it, because we can pluck one of those. Let's take this coordinate here, and we can put this into this equation here, right? So you're going to get y, which is minus 7, equals minus 3x, so minus 3 times 6, which is going to be minus 18, plus c, and therefore you should get then c is 11. Yeah, c is 11, and therefore, guys, hopefully you can appreciate that maps out nicely onto this option. And also, guys, can you see in the answers there's literally like a mirror line here, right? You have 1 minus 1, 5 minus 5, 9 minus 9, 11 minus 11. And the reason why they're giving you these options, guys, is because in this question, I think it's really easy to make a sign slippage. And if you make a sign slippage, you're basically going to get the correct answer, but probably the negative version of that. That's why they're giving you negative options for all those answers. But hopefully, guys, you didn't fall into that trap. And hopefully, if you did fall into that trap, you can understand why H11 is the correct answer. But either way, guys, I look forward to seeing you in the next video. Okay, guys, so previously we looked at this question, BMAT 2019 question 12, to do with coordinates and just a bit of algebra and just a bit of arithmetic as well. And remember, guys, in terms of the arithmetic, it was quite easy to make a silly sign slippage, so you have to really be careful with that kind of stuff. It's really common in the BMAT, especially underneath the time pressure of the BMAT, to make those errors. But hopefully, guys, with practice, that thing would be a thing of the past. But now, guys, we move on to BMAT 2011, and this question is starred. And if anything, guys, I should put a double star here, because a lot of students that I've taught before got this question wrong. So let's look at this. The first 4 triangle numbers are 1, 3, 6, and 10. The first and second difference is 2. Second and third difference is 3. Third and fourth difference is 4. And all triangles follow this pattern. The difference between the rth triangle number and the r plus third triangle number is 1, 2, 6. And it says, what's the value of r? So, guys, pause the video. Be sure to be back after that minute, where we're going to go over this really meaty question. Okay, guys, welcome back. So let's go through this. So the first thing I would suggest, guys, is that in an exam situation, if you're faced with a question like this and you really don't know what to do, what I would suggest is literally just leaving it out, because it's not worth your time, not worth, let's just say, 5 minutes trying to get 1 mark here when you could have answered 5 easy questions and got 5 points there. So that's just a thing to take into account. So, but the way you do this question, guys, this is an example of a quadratic sequence. So some of you guys might have done it in a like GCSE maths course, but me at the time when I was doing GCSE, I didn't do this myself. but it's something I learned at university anyway. But anyways, the way quadratic sequences work, guys, is you essentially work out the first difference between these numbers, right? And if you can see, guys, the first difference is, and they actually give you there 2, 3, 4, so it's 2, 3, 4. And then if you work out the differences between those differences, they're all just 2 to 3 is 1 and 3 to 4 is 1. So those differences are 1. And basically, guys, what you say is, so the quadratic, in a quadratic sequence, the nth term un is given by an squared, like a quadratic equation, bn plus c, right? And you can work out a quite easily, and that just equals the second difference, right? So second difference is 1, so a is, sorry, 2a is equivalent to the second difference, and therefore a would be half. So now we know what a is, so that's good. Then, guys, 3a plus b. So the way, the proof for this, I'm not sure. You're probably going to have to ask a maths teacher that or something like that. I'm not quite sure. But if you understand the technique, guys, they'll never ask you about proof. You just understand the technique. That's good enough. And basically, guys, 3a plus b is equal to the first of the first differences. So the first of the first differences in our case was 2. But at this point, we know what a is half. So 3 times half is 3 over 2 plus b is 2. Therefore, b again is essentially half, isn't it? So that's that. And then lastly, a plus b plus c is basically the first term, which is 1. But a is half, b is half. That means c must be 0, right? So we've got that. And now basically, guys, we know the nth term. So un is going to be half n squared plus half n, right? And now we have the rth term. So the rth term would be ur, which is half r squared plus half r, right? And ur plus 3 term is going to be half r plus 3 squared plus half r plus 3. And if you just kind of clean this up, you're going to get r squared plus 6r plus 9 there, plus half r plus 3. And then if you brush that up, you're going to get half r squared plus 3r plus the half r from there. So you're going to get 7 over 2r, which is 3.5. And then you're going to get 9 over 2 plus 3 over 2, which is 12 over 2, which is 6. Right, so that's going to be ur plus 3. And if you work out the difference, so ur plus 3 minus ur, what's going to happen is that these are going to cancel out. Then you're going to get 7 over 2 minus 1 over 2, which is going to be 6 over 2, which is just 3r, isn't it? And then you get, yeah, so that's that. And then you're going to get 6 minus 0, which is just 6. And then this, guys, should basically equal 126. Therefore, 3r would be 120 and r would be 40. So the answer you should get then, guys, is B. So hopefully, guys, that makes sense. Again, this is quite a long-winded question. And really, guys, even if I were to see this in exam pressure, probably won't be able to do this in minutes. I'll just leave it out. I'll really, guys, yeah, I'll just leave it out past the question because I can probably answer much more questions in that time. And also, guys, some of you might be maths genius. You might have easier ways of doing this. If you do, just comment down below, and that can help tons of people out there who are probably desperate to know for an easy way to do this. But hopefully, guys, that has made sense, and I look forward to seeing you in the next video. Okay, guys, so welcome back. So previously we were looking at BMAT 2018, this really beastly question, and really I should have put 2 stars here because this is a really difficult question. But hopefully, guys, that explanation, although long-winded, makes sense, and hopefully, guys, you can appreciate that sometimes it's not just it's literally not worth it to attempt such difficult questions. Next, guys, though, we will be hopefully going on to a much easier question, BMAT 2018, question 24. So it says, which one of the following is a simplification of that bit of algebra? So, guys, pause the video, just give yourself a minute. Be sure to be back after that minute, and we'll be going through the solution. Okay, guys, so the way you do these kind of questions is awfully common. Is essentially what you need to do is just try to simplify each of the numerators and just go systematically through all the numerators, all the denominators, and try to simplify as much as you can. So obviously this x over x minus 1, you can't really do anything with it, minus, but then that obviously x squared plus 3, again, you can't do anything with this, right? X squared plus 3, you leave that. But then the bottom one, you can do some of it. So you have to find 2 numbers that times to give minus 3, but add to give 2. That's 3 and minus 1, isn't it? So x plus 3 and then x minus 1. Hopefully then you can spot, guys, there's a common x minus 1 there. So that means this first one at the denominator needs an x plus 3. So times top and bottom by x plus 3, right? So you get x plus 3, x minus 1, minus x squared plus 3 over x plus 3, x minus 1. Then if you expand that, guys, you're going to get x squared plus 3x. But this step you have to be careful because now, guys, they have the same denominator, so you can just join the two numerators together. All right, so you do that, but then you have to be careful here, guys, because some students just write minus x squared plus 3, right? So they'll think then the minus is just on the x squared, is not on the 3. So you have to be careful and put this whole thing on the minus, and then divide this all by x plus 3, x minus 1, and then obviously that and that will just cancel, and you're just left with 3x minus 3, isn't it? So you get 3x minus 3 over x plus 3, x minus 1. Am I done? Though no, I'm not done, because I can simplify that further. 3x minus 1 over x plus 3, x minus 1, and then I can cancel those out. So I'm just left with 3 over x plus 3. And can I simplify that further? No, definitely not. Can't simplify that further. And therefore, guys, that's our final answer, isn't it? So the final answer, therefore, is going to be B. So hopefully, guys, that has made sense. And yes, we really look forward to seeing you in the next video. Okay, guys, welcome back. So previously looked at BMAT 2018 question 24, looking at this bit of algebra. Hopefully, guys, this was really a teaser, and hopefully it is gearing your algebra more into exam mode, and hopefully that has made sense. But now, guys, we move on to the next BMAT 2017 question 20, more algebra it seems. It says express 1 over 2x, 1 over x minus 1 minus 1 over x as a single algebraic fraction. So, guys, pause the video, give yourself a minute. Be sure to be back after that minute where we'll be going through the solution. Okay, guys, so the first thing I'd like to do in this question is this 1 over x. I'm just going to convert it into 2 over 2x, which is basically the same thing. This then allows me to join the first and the last one together. So 1 minus 2 is going to be minus 1. So I get 1 over x minus 1 minus now 1 over 2x. Now we're in basically a similar situation as last time. You just have you have essentially two algebraic fractions, and then you're looking at the denominator, seeing if there's anything similar between them. Not really, and when there's nothing really similar between them, you use a crisscross method. So you do this times this, which is going to be 2x. Whatever the sign is in the middle, that's a minus, and then do that times that, which is going to be x minus 1, over the bottom two things in the denominator times together, so 2x, x minus 1. And then if you do it, so 2x minus x is just going to be x, and minus 1, minus is going to be plus 1, over 2x, x minus 1. And then can I do anything more with that? No, not really. So then the answer, guys, this maps on nicely then onto option letter E. So hopefully, guys, that made sense, and we look forward again to seeing you in the next video as always. Okay, guys, so welcome back. So previously looked at BMAT 2017 question 20, this three-way algebraic fraction. Remember, guys, most of the time you can get this three-way, turn it into a two-way, and from a two-way it's pretty straightforward. But hopefully, guys, that has made sense. And now we move on to the next one. It says a straight line passes through the points P and Q. Which one of the following is an equation of the straight line which is parallel to PQ? So, guys, pause the video, give yourself a minute. Be sure to be back after that minute. We'll be going through the solution. Okay, guys, so welcome back. So it's talking about which is the equation of sharing which is parallel to PQ, right? So when you're talking about parallel, remember when it's parallel, the gradients are equal, whereas when it's perpendicular, the product of the two gradients, when you times the two gradients, you should get minus 1, right? So what we're going to do here, guys, is just work out the gradient first and foremost of between P and Q. So I'm going to treat this as coordinate 2, coordinate 1. So y2 is going to be 9, y1 is going to be 3, x2 is going to be 6, x1 is going to be minus 3. Be really careful, guys. The minus 3 is going to become a plus, and underneath the exam pressure, it's just easy to slip up then just think of it as 6 minus 3, whereas in fact it's actually 6 plus 3. But anyways, 9 minus 3 is 6. 6 minus 3 is 6 plus 3 is going to be 9, and that should go divide both sides by 3 is going to be 2/3. So basically any of them which has a gradient of 2/3, which is only going to be A, and the y-intercept, it doesn't matter. It can intercept the y-axis anyway, so the c value doesn't matter. Just the gradient has to be the same as 2/3, and that's obviously A. So hopefully, guys, that has made sense, and we look forward to seeing you in the next video. Okay, guys, so welcome back. So previously looking at BMAT 2016 question 4. Hopefully, guys, this question wasn't too bad, was pretty straightforward. Really just talking about, remember, guys, this topic of, straight lines y equals mx plus c is really integrated with the algebra. But hopefully, guys, otherwise, in other sense, that question was pretty straightforward. But now, guys, we move on to this one. It says rearrange this formula to make f the subject. So, guys, pause the video. Be sure to be back after that minute. And after that minute, we're going to be going over the solution. Okay, guys, so what we really want to do is we want to isolate this f term, isn't it? So the first thing we're going to do is isolate the e over f. So then the e over f is going to be a over b minus c over d, because we take this term to the other side, right? And then remember, between, obviously now, if you look at the left-hand side, between the B and the D, there's clearly nothing common. So you can just use the crisscross method. So it'll be AD minus BC over BD, right? Now we want to make F. So what I can do actually is flip both sides. So F over E then must be the same as B, BD over AD minus BC. And therefore, F must be EBD over AD minus BC. And that, hopefully, guys, you can see that maps on nicely to, I think, C. Yeah, C. That's on nicely to C. So hopefully, guys, that was a good technique to use in this question. Hopefully that technique allowed you to understand the question first and foremost. And yes, we look forward to seeing you in the next video.